the typically accepted history of mathematics, which pretty much just involves the Greeks and everything that they discovered or created about math going into European countries. But in the book, it's presented that it was Arabic cultures and a lot of people from India as well that then went into Greece and from there into Europe. I don't know if this is the flow chart that's generally accepted. As you see, it's just Greece going into Europe. But the next slide. This is the argument presented in the book, and it's much more complicated. But it's basically a bunch of cultures, including Islam, all sort of collaborated to create math that we still use today, such as the concept of zero, the decimal place, calculus. Almost everything we use in math came from multiple cultures. And I think Matt and Mr. Yanko are going further into some of these theories that we still use.
Another slide. Alright, what we got here is, as the lady mentioned, basically the history of progression of the number system. What do you guys see up here? Let's start with the first one. Indian rock. What numbers do you see? I think it's 6 and 7, right? Alright. The question mark's not quite a number, but this is basically a representation of numbers 1 through 9. And you look, it goes back down, you see 1, 2, the Indian Gwalior, I believe. So basically, this is what the Indians, they introduced, as Lena mentioned, the concept of zero. They basically set the foundation for the modern number system. However, they and the Egyptians and Babylonians had their own different sets of numbers, some based on 60, some based on other values. So the Arabs basically combined all these ideas. And if you look right here, don't look at the right one because that's not really good. But if you look at the left one, these are basically all the numbers we use today. 9, 8, 7, 6, 5 is a little weird. Just moved around and looks like that. Turn the 4 over, and that looks exactly like the 4. 3, 2, and 1. And if you think about this, I mean, could you do algebra and Roman numerals? No. It would make it so much harder. And you look at this, and you say, very simple, comprehensible system for enumeration. And then you look down and you say, oh, the Europeans, they stole this from the Arabs, so really it's the Arab contribution. And then you look and say, 1, 2, 3. Really, if you think of any subject at our school, the foundation is right there. The bottom 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Biology, physics, obviously math, even language has something to do with math itself. All right, next slide, please. All right, this is just an example based on one of the contributions the Arabs had. It's really just the place value system and the concept of using the decimal and fractions. The Arabs actually invented the distinction between integers and fractions. And if you look here, what do you guys see in the number? If you look in the column, you see 6 and you see, let's look, you see the 6 right there, and then you see the 8. What's 8 times 6? All right, so 48 right there, right? You guys see that? All right. 6, 8, 48. 4, 8. 4 times 8, 32. 2, 3. Same thing. You don't get that? Alright, I want you to look at this. This is one column, this is another column right there. What's 6 times 8? 48. 48. What's this? 48. Yes. Yes. Alright. Anyways. Run out of the house here.
What's being shown here is, wow, that's loud. 1,958 times 546. And so when you multiply 8, which is 8 ones, times 6, which is 6 ones, you get 48, right? And that's 4 tens and 8 ones. So when you're in the rightmost column, that's the ones column. 4 tens, 8 ones. So the 8 is in the ones column, the 4 is in the tens column. It's like a math lesson. When you multiply the 40, 546 times 8, you're multiplying 4 tens by 8 ones. So you don't get 32, you get 320. So the 3, that 3, that actually is 300. So that third column is the hundreds column. And then 2 tens. Do you kind of get it?
It's really just referencing. This is from the book, so it makes further reference to it. Anyways, what they're basically doing here is they're coming up with a model, like I said, place value system of nutrition and decimal. That's really all this has to show. But when you think about this, it has had a profound impact on modern mathematics and, as I said, multiple other subjects. Next slide, please. Alright. I may not talk about this just because it's a little confusing, but basically what the Arabs did was they came up with a very clear and concise way of finding the square root numbers, which was originally attributed to Kieran's method, but they basically adapted it from prior discoveries from the Babylonians and Egyptians, and they kind of adapted it to their own. And basically what they're doing here is they're saying A is the number, is the square root of the number, and when you square that number, the margin of error is E. Therefore, if you're looking for the square root, if you're looking for what squared equals 2, and you times 1 times itself, it's going to be equal 1, and the margin of error is going to be 1, because you're 1 away from 2. Anyways, they derive this formula here, and what they're doing is they're saying, first column with a 1 is an A, and you put the A in the 1, and then you take 1 divided by E, which is 2A, which is another 1, and in other words, it gives you 1.5. And although I didn't really explain it very well, what they're doing here is they're just taking that and they're plugging 1.5, which is A, into this formula. And they're repeating it. And does anybody know, happen to memorize the square root of 2? What was it? Alright, and do you see it up there? Yeah, right there. So basically the Arabs came up with this, and Mr. Yank, how relates to that? Birds are awesome.
I don't quite know what he wants me to say, but okay, I'm going to say what I told you before, which is I do know that the Greeks, they thought that all numbers were rational numbers. They thought they were all an integer divided by an integer. They were completely thrown for a loop by the notion of square roots that weren't rational numbers. So there's your intermingling.
Basically adapting it from the Greeks and other people and applying it. The Arabs took that and they made it what it is today. Next slide. I think that's probably it. This is basically the Arabs came up with the problem, and I'm sure everyone here is at least sophomore above. You've seen it in geometry or past. And basically, you realize that the Arabs came up with this, and you're using it so much, the Arabs had such a profound impact. And the interesting thing is that it was really an intermingling of ideas, as Mr. Butler and Dr. Renee mentioned, in that they took this from the Indians, the Greeks, the Egyptians, and the Babylonians, and they combined it all into one very clear, concise way of presenting information. And that's about it, Dr. Renee.